Hi everyone, today I will be teaching you Coulomb's law. That is the second topic of chapter 1, electric charges and fields. The grade you can see here is class 12 physics. This Coulomb's law in electrostatics, it states like this: whenever two unit charges are kept at a distance apart from each other, suppose these are the two places where the charges are kept, A and B, and the distance of separation between the two charges, Q1 and Q2, it is R, suppose. So this law states like this: the force of attraction or repulsion between the two charges, Q1 and Q2, is directly proportional to the product of their charges Q1 and Q2. Here you have to remember one thing: the charges, we are not taking the sign, we are taking only their magnitudes. So we can write like this: product of Q1 and Q2, and it is inversely proportional to the square of their distance. Here distance is R, so I am writing here 1 by R square. If you combine them together from equation 1 and 2, we can write Coulomb's law in this way: F is proportional to the product of their charges Q1 and Q2, inversely proportional to the square of their distance R square. But you have to keep in mind that the charges, the product that we are taking, it is their magnitude alone. To remove this proportional sign, we use a constant term. We write as 1 by 4 pi epsilon naught Q1 Q2 divided by R square, or we represent it as F is equal to this constant term. It is 9 into 10 to the power 9 Q1 Q2 divided by R square. Sometimes we can even write it as F is equal to this constant value term can be represented by small letter k Q1 Q2 divided by R square. This small letter k, or this term 1 by 4 pi epsilon naught, this value, as I have already said, 9 to 10 to the power 9 Newton meter square per Coulomb square. It's a dimensional constant. This expression gives us the formula to calculate the force with which these two charges Q1 and Q2 they are interacting with each other. Like charges, as we know, they repel each other. So this F, if they are like charges, they will repel each other, the force of repulsion. And if they are unlike, then the force will be force of attraction. You may be thinking here, this term epsilon naught, what does it indicate? This is an electrical constant. We call it as permittivity in free space. This represents permittivity in free space. The meaning is the capability to produce electric field line in free space when other objects are not nearby, surrounding. Now, its value also you need to know. Its value is 8.85 into 10 to the power minus 12 meter per meter square Coulomb square per Newton. This is the unit of permittivity in free space. This force is a central force. As you are in class 12, all of you will be knowing what is central force, the force of attraction or repulsion between two bodies from the center of mass of both the bodies. Now let us see the relationship that exists between these three physical quantities. Between, if I write epsilon, it is absolute permittivity. Epsilon naught, permittivity in free space. And if I write epsilon r, is permittivity, relative permittivity. This epsilon r is also written as capital letter K. Let us see the relationship between these three. When two unit charges are kept at a distance apart from each other in a particular medium, suppose force in a medium, then when you write down the constant, you write 4 pi epsilon. That means it is in a medium. Q1, Q2 divided by r square. If it is in vacuum, then we write one by 4 pi epsilon naught Q1 Q2 divided by r square, as we have seen in Coulomb's law, that is given in vacuum. These two equations, if you divide it, force in vacuum divided by force in medium, then we will get like this: 1 by 4 pi epsilon Q1 Q2 divided by r square, divided by, everything is divided by 1 by 4 pi epsilon naught Q1 Q2 divided by r square. And cancelling the terms, will ultimately get epsilon naught by epsilon. And this ratio, or we call it as ratio of force in vacuum to force in medium, we call it as relative permittivity, epsilon r, or we represent it as capital letter K. So from here we can know that absolute permittivity epsilon is equal to epsilon naught, that is permittivity in free space divided by permittivity, relative permittivity, or relative permittivity is equal to permittivity in free space divided by absolute permittivity in the medium. This gives us the relationship within the three physical quantities. Now, the third thing that you have to know here in this topic is about Coulomb's law in vector form. How to write Coulomb's law in vector form? Suppose two charges, as before I have taken Q1 and Q2. They are suppose like charges, say both are positively charged. They are kept at a distance r apart. Now if they are like charges, then there will be force of repulsion. So force that the first body experiences because of the second body, yes, it will be repulsion. It will represent this way. F, I'll write 1, 2. You'll read it as force experienced by the first body. This is the first body due to the second body. In the similar way, force experienced by the second body due to the first body, we represent this way: F 2, 1. Yes, we are going to write in vector form. We will represent with vector symbols on the top. Now, unit vectors these two charges Q1 and Q2, they are interacting with each other. So interaction is not this side, it is on the forward side. Q1 is experiencing interacting towards the right side. So the unit vector, when you represent it, we represent it as R12. That means the first charge is acting towards the right, and the second charge is acting towards the left. So the unit vectors we represent it as R21. So this is a representation. Now if I use Coulomb's law in vector form, I can write force experienced by the first body due to the second body is 1 by 4 pi epsilon naught Q1 Q2 divided by R square, and then we have to put the unit vector. See here F12. This vector and this vector, they are pointing in the same direction. So we'll take this one R21. And force experienced by the second body due to the first body F21, we can write it as 1 by 4 pi epsilon naught Q1 Q2 divided by R square. This time this force F21 is acting on the right side, so the unit vector right side is 12 R12. Like this I represent. The first one I am taking as equation number 1. To make the direction equal, as you know in vectors we have learned, this unit vector R12, if I make R21, then the direction will change. So this second statement, if I write like this, 1 by 4 pi epsilon naught Q1 Q2 divided by R square, if I write it as R21, then the direction has changed. So plus in vector, when the direction changes, plus gets converted to minus. So this will become minus. Let me take this as equation number 2. This is the way to represent Coulomb's law in vector form. Now if you compare equation 1 and 2, we can see that the right hand side quantities all are same. Only the difference is here towards the left hand side. F12 is equal to minus F21. If right hand sides are equal, left hand side also must be equal. F12 is thus equal to minus F21. So Coulomb's law in vector form follows Newton's third law of motion. This equation, if you look carefully, this is an expression of Newton's third law of motion that we have learned in class 11. Like this we have learned, force on first body due to the second body is equal to force on second body due to the first body, but with a negative sign. Action and reaction are equal and opposite. So we can say that this obeys Newton's third law of motion. Now let us do some numericals based on Coulomb's. Let us solve one numerical question. I have written here, you can see the electrostatic force on a small sphere of charge 0.4 microcoulomb. So when you do the solution, the first charge is given to you Q1 0.4 microcoulomb. Then SI unit of charge is coulomb. So we write 0.4 into 10 to the power minus 6 coulomb. Due to another small sphere of charge, Q2 is minus 0.8 microcoulomb. That is minus 0.8 into 10 to the power minus 6 coulomb. In air is 0.2 Newton. The force is given as 0.2 Newton. So from here we are asked to calculate the distance between the two spheres. So we can use Coulomb's law. Using Coulomb's law, F is equal to small letter K, Q1, Q2 divided by R square. You can write on the formula like this. After you write on the formula, you can place the values. Force value is given to you, it is 0.2, that is equal to K value is 1 by 4 pi epsilon naught 9 into 10 to the power 9 multiplied by the magnitude of the charges. Remember here we have to take the magnitude, don't take the sign. It is 0.4 into 10 to the power minus 6 multiplied by 0.8 into 10 to the power minus 6 divided by R square. Now cross multiply, R square will come towards your left, and this 0.2 Newton you can place it down. 9 into 10 to the power 9 into 0.4 into 10 to the power minus 6 into 0.8 into 10 to the power minus 6 divided by 0.2. 0.2 into 2 times is 0.4. After that, the numbers will multiply it. If you multiply the numbers, you get like this: 144 into 10 to the power minus 4. It will be in meters. We are doing in SI unit. All the units we have changed into SI unit. So R will be square root of 144 into 10 to the power minus 4. So here it will come as meter square, sorry. Then its value will be 12 into 10 to the power minus 2 meter. Like this you can calculate the distance between the two spheres. Then the second one, that is, what is the force on the second sphere due to the first sphere? The force will remain the same. Only the direction will change. The second sphere also will exert the same force as the first sphere exerts on the second. Then I am giving you one assignment. You can try at home and see. Here is your home assignment. You can try and see this question. The electrostatic force of repulsion between two positively charged ions carrying equal charge is this one. This value gives you the force, as its unit is Newton, when they are separated by a distance of 5 angstrom unit. The question is, how many electrons are missing from each ion? So in this question you will use Coulomb's law in electrostatic. F is equal to K Q1 Q2 by R square. And using this you will find out the value of Q, because both are of similar charge. So Q1 Q2 you can write it as Q into Q. It will become Q square divided by R square. The distance is given in angstrom unit, 5 angstrom unit. It is 5 into 10 to the power minus 10 meter. So you can use that value, and then you can first find out force value is also given to you. You can first find out the value of Q. After you first find out the value of Q, what you have to do is use your contention of charge. This Q is equal to NE. From there, N you can find out Q divided by E. With this formula you can find out the number of electrons that are missing from each ion. Thank you and have a nice day.